All right, so let's talk about the one part of the SEM that is inherently different from light microscopy and from transmission electron microscopy, or TEM. So both light and TEM generate the whole image at once with a single beam. But scanning electron microscopy is inherently different because we take a fine beam and scan that, as the name implies, across the surface in order to generate the whole image. So we're only collecting information from one small region at a time, and we're building that up by scanning across the image. So that's inherently what makes this different. And so this next one basically shows us how that's done. So if you remember the old cathode ray tubes, or CRT displays, you might have actually seen this before, but it's really similar to how the SEM works. So we basically start the beam at a given point, so typically up here in the top left, and we hold at that point for a given amount of time to collect enough signal to generate the image, and then we go to the next one, which is on the right, and we go to the next one, just as this thing is showing you here. So we basically deflect the beam and cause it to raster or move, sorry about that, raster or move the beam in the XY position such that we get signal from each point, and then it moves, and then it goes to the next one. So this is kind of a slowed down version of what you see. So that's very similar to what you might have seen in old CRT displays. So we basically move from one place to another, and we use these scan coils. So this scan coil here basically causes the beam, the electron beam, to deflect into the different positions, XY positions we need. So this is basically an electromagnet that allows us to move the beam in the way that we need it to move. And so that's how we generate a larger image, by collecting signal at very small points for this small beam. So each position that the electron beam is held at, the area of the sample in which the signal is collected, is known as a picture element, or what you know as a pixel. So this isn't the exact same as the beam. So obviously the two are connected, but we can have a beam diameter that's much larger than our defined pixel area. And when that happens, if we're getting signal from a larger area than just the one pixel, then what happens is that becomes blurry and out of focus. And so we need to effectively adjust our beam diameter such that it fits within the pixel size or is smaller. That way we can resolve each pixel. So that's really important. But again, keep in mind, the pixel area is something sort of we define with the software, and the beam diameter is something we control with the instrument. And so we have to make sure that those two fit so we can get the sharpest focus, as you see here. So the limitations that we have is at the lower magnifications, the resolution tends to be limited by the pixel size, because our human eye can only resolve 100 microns. However, at the higher magnification, our resolution is going to be limited by the beam diameter. And so there's an inherent limit that we have with that. And so because the human eye can only really resolve 100 microns, then basically that's what we're going to choose. That's what we tend to choose for pixel size, because anything smaller is really unnecessary because we can't resolve it, right? So we want to kind of keep it in that frame.